So again, thank you very much. I'm ready to move now to the ICT part of the water mining project. So in WP7 what we propose is to mine data as well as water. And we develop a few very interesting digital tools to enhance aspects of the project. So what are these tools? In WP7, we work on mainly three areas. The first area is about making the demonstrations more efficient. So here we develop within task 7.1 and then demonstrate in 3 cases in task 7.2 online dashboards that are coupled with advanced artificial intelligence technologies, mostly machine learning type of algorithms and analytics that support real-time monitoring, control and optimization of the water mining solutions. The second area is about supporting the demonstration character of the cases. So here we develop in 7.3 and then demonstrate in 3 cases in 7.4 augmented reality applications to provide, if you like, an immersive experience of the water mining solutions to different audiences visiting the demo sites, so stakeholders, market representatives, and the public. And the last area, 7.5, is about supporting the market for the products of these water mining solutions by developing a water mining platform that brings producers of products, so stakeholders like municipalities, industries, desalination plants, in touch with potential end users of material, so industries, farmers, and so on, in a more distributed model. Now, there are several partners involved in these 5 tasks, as you can see. And later today, we will have an opportunity to hear from all of them in our breakout session, so stay tuned. Now, as you can see from this Gantt chart, we have already started with the development of the dashboards and the augmented reality applications. Actually, we are not starting from scratch, as I will show you in the next few slides. So let's dive into each technology, starting with the dashboards. So the target here is to support evidence-based decision-making at the demo plant level by taking advantage of high-resolution data streams from the on-site monitoring systems. So what we plan to do is to develop a highly customizable online system that will enable real-time fusion and analysis of data. It will allow for setting alarms for unusual events, as well as provide advice to operators for process control and optimization, depending, of course, on the requirements from the demo cases. Some of the more, let's say, clever elements under the hood are going to be based on novel AI techniques, such as reinforcement learning, which is a really promising family of algorithms that does exactly that. And as suggested, we are not starting from scratch. We are building here on a system called NESI. And NESI is this highly customizable platform which can manage high-resolution data from IoT agents, so things like sensors and smart meters, and can translate data into information using analytics, such as machine learning that I talked about, and reinforcement learning in particular, and help visualize information to end users. So the core system has already been deployed in a range of smart monitoring and control contexts, although not a treatment process optimization yet. And I have included in this slide 3 examples of NESI dashboards customized for water consumption, remote control of sewer mining units, perhaps the closest application to water mining, and management of subsurface water systems. So quite a versatile lot. And we will talk more about NESI in the breakout session of WP7 later on. Something worth noting, I think, is that we are in the process of upgrading the platform NESI within a project called Pharo for Water to be Pharo compliant. And Pharo is this set of interoperability standards and technologies that the EU has been supporting. This is important because it allows us to develop what we call generic connectors to couple NESI with external simulation models and AI tools running on external platforms, and of course legacy systems, which is very relevant for this project, which has a rather wide set of data sources, models, machine learning technologies that need to be merged. Of course, the proof of the pudding is in the eating, as they say. So NESI will be customized in task 7.2 to the specific requirements of 3 demo cases. And this means that NESI will connect to the monitoring systems at the case level, also connect to case-specific simulation models when these are available, AI applications on partner servers and so on. And also means that we will select and customize the visualization of the platform in a way that is suitable for each case study operator. So this is the power. Not every operator needs to see the same things, and these cases are different enough. So we will customize to their specifications. So what are these cases? So we talked about cases already, some of them. So I'll just simply point towards the ones selected for 7. We've selected one case per water mining theme, as Dimitris said earlier. So the first case is the Lampedusa desalination plant in Italy, which belongs to the sea mining group. The second case is either the wastewater treatment plant of Utrecht or the wastewater treatment plant of Pharo, to be defined soon. And these both belong to the urban mining group. And the third case in which we will develop and deploy is the plant at the Hexion site, which belongs to the industrial mining group of cases. Now, on to the second main tool, the augmented reality. Here we plan to develop experiences, augmented reality experiences, customized for each stakeholder. So from business to municipalities to citizens, each stakeholder visiting the demo sites will have access to augmented reality through smartphones to help them to better understand what is happening on site. And this is often very difficult to see with the naked eye, if you like. And the intention here is to improve awareness and understanding of the opportunities the solutions imply. And to make this experiences really versatile, we are developing 2 components, an AR mobile-based application that you can see on your smartphone, and a web-based authoring tool, so a front-end and a back-end component, if you like. So using the authoring tool, the augmented reality mobile application will be able to deliver content which is tailored to the needs of site visitors. So what is content? Content can be 3D models, it can be images, it can be videos, graphs superimposed on the physical reality of the site. We can offer navigation capabilities, a sort of self-guided tour through the demo case, if you like. And we can also use gamification to make these experiences more intuitive and playful. We all know that we learn better when we play because we are more open and less risk averse. So we plan to use this to the project's advantage. And this application also builds on past developments. Here we work on a relevant application from a project called NextGen, which is also a project looking at water in the circular economy. Now, of course, there's quite a lot of upgrade, a lot of customization, adjustment that we need to do to make the tools suitable to the water mining mission. But the point I would like to make is that we don't start from scratch, and hence, as Dimitris said earlier as well, we plan to have a proof of concept very soon so that the partners can see, especially in the cases, and then, of course, this simplifies things enormously. Talking about the cases, the augmented reality application will also be customized for the 3 cases, which means that we need to generate content for the augmented reality application with the help of the case owners, of course, and at the same time in collaboration with 11. We need to plan, and we plan to run a series of showcases to increase awareness, also supporting business activities, for example, business activities related to Work Package 9. Now, last but not least, we will develop the water mining platform to link wastewater owners, so desalination plants, municipalities, and so on, with potential end users of the materials recovered, so farmers, industries, and so on. And this platform will help essentially market uptake of the recovered products from the water mining cases by allowing end users of recovered materials to register data about market requirements, so demand, use, quality, quantity characteristics, and the platform will match buyers and sellers based on the kind of materials, but also the thresholds in terms of quality and quantity that are required, which is very important. Actually, Mark made a very important point to this effect in his keynote earlier on. So again, we are on solid footing here. We plan to build on and extend what is called the online brine platform, which was developed in a project called Zero Brine. Quite a lot of you have worked in Zero Brine. Well, we all know that Zero Brine was a lighthouse project, a success story for the Commission. And you can see this in the screen, the dashboard of the online brine platform as it stands now. But of course, we plan to extend it, include more industrial sectors, more materials, new functionality. The outputs feed into 5 deliverables and a milestone. Although the first is in 2 years' time, we have already started working, and this was also a point raised earlier on in the breakout session with Dimitris. We plan to move quite a few things earlier on. And of course, we don't work in a vacuum. 7 links up with work packages that work on the 3 demo cases, of course, where the dashboard and the augmented reality technology will be demonstrated. It links up with 2, work package 2, to see how augmented reality can be used to support stakeholder engagement in experiencing and visualizing circular economy water technologies. And of course, it links to 11 for training and dissemination purposes, and 7 results will be used also to some extent, and I mean to some extent for the cases in which we will have data within Work Package 8 to support assessment of individual technologies and visualization of indicators. And I would like to close with some initial actions that are already on the way. We have established a close collaboration among the development team, which is always number 1. We will now link up with the pilots, case owners, and their R&D partners to collect information on requirements and create common mental images, if you like, of what the deliverables will be. We are also starting to develop some of the more advanced and interesting and innovative components of the work, such as the reinforcement learning techniques for the control and optimization modules based on historical data and quite a few more. So we are just starting. More will come out and be discussed in the breakout session. So watch this space, as it were. Thank you very much.